And today I'm going to talk about the question bank discussion based on the shift registers using behavioral modeling. So far we have discussed different questions based on the different modeling styles, right, in the Verilog. So today in our topic we are going to discuss something about the behavioral modeling. Okay, the questions based on or else the modules or the different electronic devices which are based on the using the behavioral modeling style. So here we have a question. Write a Verilog code for implementing 4-bit universal shift registers in behavioral modeling using case statement. So whenever you got a question, the first and foremost thing is just you have to read the question and analyze the question. So in this question, there are three things to remember, and just there are three things to ponder. So first thing is we have to write a Verilog code, and that Verilog code should be written with respect to this 4-bit universal shift register. So we have to be aware of what is universal shift registers, and then in which style we have to write the code. Okay, so here in the behavioral modeling style we have to write the code, and that too in the behavioral modeling style using case statements we have to frame the Verilog codes. Okay, so these are the important things we have to remember. And then let's start. What is the 4-bit universal shift register? So basically we all know what is a register, right? So registers are nothing but they are the storage devices. They are the storage elements. That means what they store they store a bit of information. Okay, so registers probably they contains the flip-flops, group of flip-flops or group of latches are nothing but their registers. So registers contains the different information. Okay, and that information can be carried out with the help of the peripheral devices or the with the other devices storage elements like the flip-flops or the latches, right? So in the registers we have different types of registers as well. And now basically coming to this 4-bit universal shift register, as the name indicates, it is a universal shift register, right? It is a shift register. That means what these registers can be shifted. Okay, you can see the transformation or the transferring of data can be done from one end to the another end. So here in the shift register, there are different ways to shift the bits. One is serial in and serial out, serial in and serial out, serial in and parallel out, and parallel in and serial out, and parallel in and parallel out. So these are the different ways we can so that we can shift the bits, okay, shift the registers from one end to the another end. And also very minute thing else it comes to our mind if you are pondering about this 4-bit universal shift register. That means what we can shift the bits from the left to right or else from the right to left. If you are shifting your bits from left to right, then it is nothing but the left shift right, okay, left shift. And if you are shifting your bits from the right to left, then it's a right shift, right? So this is what the basic things that we can see in this universal shift register. So here the name indicates the 4-bit universal shift register, so that we are going to shift up 4 bits of data, 4 bits of register, 4 bits of information can be shifted from left to right or from the right to left. So the universal shift register is a register where it can shift the data in both directions. Okay, it can shift the data in from the right to left or else from the left to right. In other words, it's a universal shift register, is a bidirectional shift register. Yes, obviously it's a universal shift register, so that another name we can give is it's a bidirectional register as well. Why? Because it can shift from left to right and as well as from the right to left. And then universal shift register, USR, universal shift register, is a combination of design of bidirectional shift registers and unidirectional shift registers with parallel load provisions. So they can also shift the bits in a unidirectional way as well. Okay, if they are shifting their bits in a universal way, then they are shifting it in a one way with the parallel load provisions, right? So we can say that it can shift the bits from the bidirectional, or else it can shift the bits in a one-way direction. And also universal shift register, it can perform parallel to serial operation, right? So as I said, you serial in, serial out, parallel out, like that. So it can shift the bits from parallel to serial operation as well. Okay, so first loading parallel input and then shifting. So what parallel to serial operation. What is this parallel to serial operations is, in this parallel to serial operations, there are four main categories of shifting the bits can be done. Okay, one is with respect to SISO, that is serial in, serial out, serial in, parallel out, serial in, parallel in, serial out, and parallel in, parallel out. So what does this serial in, serial out? It means that the bits are serially first loaded, and then it is shifted parallel. It is shifted serially. Okay, at the input part it is loading serially, and at the output part they are what are they doing? They are just shifting the bits. Okay, for example, let us consider serial in, parallel out. So what does it serial in, parallel out means? The serially, the input, it is loading the bits serially, and it is shifting the bits parallelly. Okay, so here we are seeing the two way of shifting and loading is done. One is with respect to serial, and then with respect to the parallel. Okay, and then also a USR can also perform serial to parallel operations. So these are serial to parallel. So this is what SIPO. It is serial input and parallel output. That means what? First it shifts, and then it retrieves the parallel output, and then the desired operation is then specified by 2-bit control signals. So all these operations, all the shifting and loading can be done with respect to the control signals, right? And then we will see what is this bidirectional shift registers and universal shift registers. Bidirectional shift registers are, they can shift data in both the directions, from left to right and from the right to left. So it is 0, 0, 0, 1. So it can shift its data from left to right, and also it shifts from right to left. Okay, from right to left and from left to right as well. So that's the name we are saying that it is a bidirectional switch. And also this type of register is used for applications that require both shifting and shifting back to the data. That means what? It can shift. Okay, it can shift, or else it can transfer the data from one end to the another end, and then after immediately from this end it shifts back to the other end. Okay, this is what the bidirectional shift register. And now coming to the universal shift register. So universal shift register is nothing but it can perform any of the above operations using control signals. So this universal shift registers have some control signals, and so that it can perform any kind of operation. That means what? From left to right or from the right to left. Okay, by using this control signals, it can shift data in any direction and perform any of the above operations. So it can shift the data, and in any direction it can shift the data. So that's the name we are calling it as a universal shift register. And also this type of register is used for applications that require flexibility in data transfer and manipulations. So why we are opting, or else why we are choosing this universal shift register is we can achieve the flexibility. Okay, we can achieve the flexibility and also the data transfer and manipulations. Okay, and manipulations can also be done. What sort of manipulations is, for example, if you're shifting your data, that is 0, 0, 0, 0, 0, 1, 0. Okay, 0, 0, 0, 1, 0. So this type of data is transferred from A to B. So with the help of left shift, so the bits are shifting from the left to right. So using left shift operation, what I have to do is I need to shift from A to B. So in shifting, what happens is sometimes due to the disturbances, okay, due to the disturbances, what happens is instead of receiving 5 bits of data, sometimes I may receive 4 bits of data. That means what? 1 bit of data is somewhere it's collapsed. Okay, it vanishes. So what happens is I can manipulate here. So I can add up 1 bit. So this is how we can change, or else we can alter such sort of things in the universal shift register. Okay, then each type of shift register has its own unique characteristics and applications. So each and every shift registers, they have their own specifications. They are different, they are unique, and they have their own characteristics as well. And choosing the right type of register is essential for the success of any digital circuit design. So here basically you have to concentrate more on the choosing of the registers. So some registers, what happens is the registers, they are easily enabled to give and take the access from the while they are shifting, right? So sometimes what happens is some chaotic situations we will find when you are shifting your bits from source to destination. So it's all important that you have to be very careful if you are if you have to be very careful in choosing the right register. Sometimes what, for example, I can say that here I have A, B, C, D registers. Okay, registers. A is having 0010, B is 0001, C is 0100, D and 0010. So now I have to send my bits as 00100. So 0010. So each and every bit that I have got, I've chosen one bit from all the 4 registers. So what happens is, while shifting, while considering, okay, while choosing, instead of 1 bit from here, I have already choose 1 bit from C, and again I have to choose 1 more bit from D. So instead of choosing bit from D, what happens is I am choosing bits from C itself. So there is a problem occurred. So we have to be very careful from which registers you are choosing the bits, right? And then this is a register operation control signal. So based, we can here see the operation based on the control signal. See here we have the 2 control signals, 0 and 0. So for 0 and 0, what sort of register operations we can observe is there is no change. And if it is 0 and 1, so it is 0 and 1. So here we can see there is a 1 shift right. Right? If it is 1 and 0, it is shift left. And if it is 0 and 0, what happens? Both the control signals are of high bits, and then it is a parallel load. Okay. And then we will see the advantages of the universal shift register. So what are the advantages are? Advantages means they can perform 3 operations basically: shift left, shift right, and parallel loading. So this universal shift register, the name universal shift register is, it loads, okay, it performs the 3 operations, that is shifting to the left, shifting to the right, and also with the parallel loading. Okay, that means parallel loading is nothing but serial in, parallel out, like serial in, parallel out, parallel in, serial out, parallel in, parallel out, serial in and serial out, right? So this is what it can do. The universal shift registers can do all these things. And then the universal shift register acts as an interface between one device to another device to transfer the data. Yes, obviously the universal shift registers. So for example, here I have a device 1 and here I have a device 2. What happens is, just to transfer the data between these two, device 1 to device 2, this universal shift register, they acts as an interference. Okay, they will interfere and they just help us to travel, or help us to transfer the data from the one device to another device without any interruptions. Okay, and then the Verilog code. Coming to the Verilog code. Okay, Verilog code. What in the Verilog code we will see that the Verilog code is a 4-bit universal shift registers. So here we are starting up with the keyword module, keyword, name of instance name, shift register, and the port list. So in the port list, we are mentioning all the input, output, and as well as the control signals and also the clock signals. And then input is clear and clock, and input is 2 bits of data, S0 and S1, that the selection lines, and the output is 4 bits, right? 4 bits, 3:0. So 4 bits of output data, and output is I'm storing in the 3:0 bit of data type register. So in the register data type, I'm storing 3 bits of 0. Okay, and now I'm writing this code using behavioral modeling. So as we know that the important point to be remember if you're writing your code in behavioral modeling is you have to mention the keyword. Okay, the keyword pertaining to the behavioral modeling always at the rate POS clock. Okay, as these are the registers are nothing but the group of flip-flops. Right, so flip-flops, positive edge clock. We know the positive edge and negative edge. Positive edge from 0 to 1. Okay, the high, if it is taking its transition from 0 to high, it is a positive edge, and if it is taking from high to low, then it is nothing but the negative edge. So here, always at the rate POS clock, and now I'm begin. Okay, we are beginning with the if. Okay, if see, our question is we are going to write. We need to construct a Verilog code using Verilog code for 4-bit shift register, universal shift register, using what? Case statement. So this is what we have to write our code. All these things we need to include. That means what? Our code must be in terms of using case statements. So always begin if clear. Okay, if everything is clear, output should be 0000, right? So it's a 4-bit universal shift register. So our output should be 0000 when it is clear. Then else, okay, if it is clear, else what happens is begin. Okay, based on the selection lines, right? So these are the selection lines. So when S0 and S1, in the previous slide we have discussed what is this S0 and S1. So these are the selection lines. Based on the selection lines, we can able to know how the register is transferred between the two devices. So when both are 0, the selection lines, we get the output, or else the register operation is no change. If both are 1, right? If both are 1, we see that there is a parallel load. Okay. So this is what we are going to write in terms of Verilog code. So in the Verilog code, case selection, 2 bits of data out, which is equals to out, and then now see here we are writing the we are getting the output with respect to the selection lines 0 0 0 1 1 0 and 1 1. We know for 0 0 and 0 0 it is no change, and if it is 0 0 0 1 it's going to be a left shift, and if it is 1 0 it is going to be a right shift, and if it is 1 1 it is going to be a parallel load. Okay, it is parallel load. And then end case. Okay, the case statement got ended with respect to the selection lines. Then what happens is end module. So we have done of writing a code in terms of case statement using case statements. All that we need to do is for each and every module, or else a basic building blocks that you are considering, remember that based on the selection lines. Okay, based on the selection lines, we know this well. Based on the control lines, right? Based on the selection lines and control lines, the output is going to be enable or disable. Okay, we are going to observe the output only based on the selection and as well as the control lines. And also in this universal shift registers, based on the selection lines, by using the case statement, if A is equals to 0 and if A is equals to 0 and B is equals to 0, what sort of output that we are observing is there is no change in the output. If if my A as 0 and B as 1, it means that I'm going to shift, or else I'm going to shift it to a right shift. If not, if okay, case again, A as 1 and B as 0, and then my output is going to be as a right shift, and then finally and 1 as 1. That means what? Parallelly I'm going to be load my outputs are it's loading and shifting, right? So when both my selection lines are 1 and 1, it means there is a parallel load. Okay, then finally end cases. If you are starting your code with begin, then you have to start with end, right? And if it is a end module, and you have to start end with end module. So this is how you have to write your code. And now we will see the test bench code. So for each and every Verilog code, you have to write the test bench code as well. This test bench code, it differs with minute things where this module and universal shift register test bench, universal shift register test bench, and then register. Okay, these are the data types. Okay, data types are meant to store the inputs and as well as the output, the representations of the input and as well as the output. So register 3 is to 0, that's 4-bit, and we are writing a code in terms of behavioral modeling. So register, clock, and clear, and then the selection line. So how many selection bits that we are considering? It's 0 0. Okay, 2 selection lines. So 0 is to 1. That means 2 selection lines. And then wire. Wire is meant for the connection purpose. Okay, wire is meant for the physical connection of between 2 elements. So wire 3 is to 0. That is 4-bit of output. And then universal shift registers with respect to all parallel, clock, clear, selection line, and output. Okay, whatever you are writing over here in this, all these things are mentioned in the port list. Okay, only thing is just for the displaying purpose, we are moving on to this test bench. And then initial begin clock. Okay, when clock is 0, so here there comes the test bench, the delays. Okay, with how much of delays the output is observed. This all things can be written in terms of in the test bench Verilog code. So repeat 100. So here 20 nanoseconds of delay, the clock signal is enabled, and then end. And then initial begin, and for one more case, so here we have done with 0 0, and now we are going with 0 1. So initial case 4-bit 1 0 1 1. So selection bits are 0 and 1, right? So selection bits are 0 and 1, and then we are cleared with 1 bit of 0, and then finally with 40 nanoseconds of delay. So before it is 00 with 20 nanoseconds of delay, we got it as there's no change, and with 40 nanoseconds of delay, the selection lines as 0 and 1. We say that the parallel output, it could be 1011. Okay, parallel output, it could be of same one bit of 0, and then with 4 nanoseconds of 0 as 4 as 40 nanoseconds of delay, we are 10. Okay, again at 40 nanoseconds of delay, what happens is we are getting the observe. That means we are shifting the bits towards the left. This is, we are shifting the bits towards the left, and here we are shifting the bits towards the right with 40 nanoseconds of delay. And then for 1 and selection for 1 what happens again at 40 nanoseconds of delay? What are we doing is parallelly we are dumping, that is parallel load. Okay, parallelly we are loading all the bits. Okay, all the 4 bits into the all the 4 bits parallelly loading, and then finally end module. Okay, so this is one of the best example that you can write your code in terms of behavioral modeling using case statements. If you observe here, we have used case statement, right? So we have used the case statement in order to write the particular code. So in the exam point of view, if you have come across to write the code, construct the Verilog code using 4-bit shift registers with respect to the case statements, then this is how you have to mention. First thing is, in the Verilog code, you have to mention the keywords, instance name, and the port list. And then separately, you have to initialize the inputs and as well as the output, and based on the modeling style. So for this example, you're writing your code in the behavioral modeling. So you have to mention the keyword always at the rate positive edge. So as these are the registers, we know that the flip-flops and latches are one of the major, they do carry the information bits. So always at the rate positive edge. And then we have to begin our main code with the case statement using the case statement. So based on the selection lines, we can able to know how the bits are shifting towards the right or towards the left. And also we can able to know based on the selection lines how the bits are loading parallelly. Okay, how the bits are loading parallelly. And this is how you have to write. And finally, you need to terminate your code with the end module and end case and end module. As you have started your code with the case statement, and then you have to terminate your code with the end case. And so you are finally, as you have started your code with the keyword module, and then you have to end with the end module. Okay, this is how you have to write your code. And do remember that for each and every code, each and every module, each and every Verilog code that you are writing for different modeling, in the different modeling styles for different electronic circuits or else devices, you need to remember that you have to write the test bench code as well. Okay, there's not much difference. You will see only very few differences, that too in the initial state, initializing the inputs and outputs with respect to the data types, right? So this is what you have to write your test bench code as well for each and every module that you are considering. So this is all about question based on the 4-bit universal shift register. I hope you all understand. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.